Hello, good day. Welcome back to another math video. This day we'll be talking about solving quadratic inequalities. If you haven't watched our previous videos on the introduction of quadratic inequalities, we're suggesting that you should watch that first before proceeding to this lesson. We'll have example 1. Solve the following quadratic inequalities. So we have here x squared minus 3x minus 18 is greater than 0. The first thing that we should do is to identify the zeros of our quadratic inequalities. So if you have noticed here, the quadratic expression x squared minus 3x minus 18, we can actually factor this out. So we look for a factor of negative 18 such that when added, that will give us negative 3. So in this example, we will have negative 6 and a positive 3. Negative 6 times 3, that will give us negative 18. Negative 6 plus 3, that will give us a negative 3. So we will write now the quantity of x minus 6 times the quantity of x plus 3 is greater than 0. So to find the zeros of our quadratic inequalities, we will equate each term to 0. So we will have x minus 6 is equal to 0, and we will also have x plus 3 is equal to 0. Solve for x, we will now have x is equal to 6 and x is equal to negative 3. Next step, we will plot our zeros to our number line. So we will have here an open circle at 6 and an open circle at negative 3. Why did we use an open circle? Because again, it's an open interval, as you can see. So if you notice, our number line is now divided into 3 parts. So we have this area here beyond negative 3. We have this area in between negative 3 and 6. And we also have this area beyond 6. So we will look for the values of x that will satisfy the inequality x squared minus 3x minus 18 is greater than 0. So first, we will test the number after negative 3. So in this example, I will be using negative 4 as the value of x. So we will have negative 4 squared minus 3 times the negative 4 minus 18 is greater than 0. This will become 16. This is positive 12 minus 18. So we have 10 is greater than 0. Is this true or false? This is true. What about the numbers in between negative 3 and 6? So we will pick any number. We could actually have negative 2, negative 1, 0, 1, 2, 3, 4, and 5. In this example, I will be using negative 2 as the value of x. So we will have negative 2 squared minus 3 times the negative 2 minus 18 is greater than 0. This will become 4. This will become 6. So we will have 4 plus 6 minus 18 is greater than 0. And we will have negative 8 is greater than 0. Is it true or false? This is false. And we have the last portion. So the numbers beyond 6. So in this example, I will be using the positive 7 as the value of x. So we will have 7 squared minus 3 times 7 minus 18 is greater than 0. This will become 49. This is negative 21 minus 18. So that will give us 10 is greater than 0. Is it true or false? It is true. So meaning to say that the only possible values of x will be greater than 6 and less than negative 3. We cannot have the value of our x among these numbers, negative 2, negative 1, 0, 1, 2, 3, 4, and 5, because again, it will make our inequality statement false. So we will now write that x will be less than negative 3 or x will be greater than 6. The only values that will make our inequality statement true is when x is greater than 6 or x is less than negative 3. We'll have example number 2. So we have the inequality x squared minus 1 is greater than or equal to 0. In this example, we are having greater than or equal to, meaning to say we are dealing with a closed interval. So again, first thing that we should do is to find the zeros of our inequality. And for this example, we'll be utilizing the extracting of square roots. So we will write x squared is greater than or equal to 1. Extract the square roots. We will have x sub 1 is 1. X sub 2 is a negative 1. So again, in our number line, we will be having a shaded circle because again, we are having a closed interval. So negative 1 and 1 will be part of our solution. So again, as I said earlier, this number line will be divided into 3 segments. So we have this area here, the area in between -1 and 1, and the area beyond +1. So we'll try to check first the values after -1. So we will write x squared minus 1 is greater than or equal to 0. So in this example, we'll pick -1 because again, it's a closed interval. We can include -1 as our x. So we have -1 squared minus 1 is greater than or equal to 0. -1 squared is 1 minus 1. That will give us 0. And indeed, 0 is equal to 0. So this statement is true. How about the numbers in between? So we will have 0. You could have zero point -0.5, negative zero point -0.5. But for this example, we'll pick 0. So we have x squared minus 1 is greater than or equal to 0. 0 squared is 0 minus 1. That is -1 is greater than or equal to 0. And again, we know that this is false. We'll have the third region, numbers from 1 to positive infinity. So we will have x squared minus 1 is greater than or equal to 0. We'll pick 1 as the value of x. So you have 1 squared minus 1 is greater than or equal to 0. 1 squared is 1 minus 1, 0 is equal to 0. So therefore, the statement is true. So meaning to say, the only possible values of x that will make this inequality correct, x squared minus 1 is greater than or equal to 0, is when x is equal to or less than -1, or when x is greater than or equal to 1. So that will be the possible values of our x to make this inequality correct. What if we have x squared minus 3x plus 18 is less than 0? Again, first thing that you should do is find the zeros of our inequality. So we have x squared plus 3x minus 18. So what will be the factors of -18 such that when added, it will give you a +3? So we have +6 and a -3. So we will write the quantity of x minus 3 times the quantity of x plus 6 is less than 0. And find the zeros. We will have x minus 3 is equal to 0. We will also have x plus 6 is equal to 0. X will be +3 and x will be -6. After that, we'll proceed to our number line. So since we are using a less than sign, meaning to say that this is an open interval, so we'll be using the open circle. So we'll place that one above -6 and above 3. So again, this number line is now divided into 3 parts. So we have the numbers after -6, in between -6 and 3, and numbers after 3. So we'll check which among this group of numbers will make our inequality statement correct. So we'll pick -7. And again, I would like to emphasize that you can pick any number from -7 towards -infinity. So we have -7 squared plus 3 times the -7 minus 18. This will become +49. This is -21. So that will give us 49 minus 21 minus 18 is less than 0, and 10 is less than 0. Is it true or false? It's false. So meaning to say that the numbers on this side of the number line will make our statement or inequality statement false. What about the numbers in between -6 and 3? So we'll try. So we have -5 squared plus 3 times -5 minus 18 is less than 0. This is +25. This will become -15. So we will write 25 minus 15 minus 18 is less than 0, and that will give us -8 is less than 0. Is it true or false? It's true. How about the numbers after 3? So we'll have +4. 4 squared plus 3 times 4 minus 18 is less than 0. This is 16. This is 12. So we will have 16 plus 12 minus 18 is less than 0. And that will give us 10 is less than 0. True or false? It's false. So meaning to say that the only possible values of x is when x is in between -6 and +3. Again, these are the only values that will make our inequality statement correct. So we will write x is greater than negative 6 but less than 3. If you do have questions and clarifications, please do not hesitate to ask. Example number 4. So we have x squared plus 4x minus 12 is less than or equal to 0. So again, first thing is to find the zeros of our inequality. So in our quadratic expression, x squared plus 4x plus 12, what will be the factors of 12 such that when added will give us a positive 4? So we will have 6 and a negative 2. So we will write the quantity of x plus 6 times the quantity of x minus 2 is less than or equal to 0. Solve for the zeros, we will have x plus 6 is equal to 0, x minus 2 is equal to 0, giving us x is equal to negative 6, and x is equal to positive 2. So again, in our number line, we are dealing with a closed interval, so we'll be utilizing the shaded circle. Correct. So we will have negative 6 and 2. So again, we'll test the number from negative 6 towards negative infinity, the numbers from negative 6 to positive 2, and the numbers from positive 2 towards positive infinity. So we will have x squared plus 4x minus 12 is less than or equal to 0. So we'll have negative 7. Negative 7 squared plus 4 times negative 7 minus 12 is less than or equal to 0. This is 49. This is negative 28. So we will have 49 minus 28 minus 12 is less than or equal to 0. That will give us 9 is less than or equal to 0. And this is false. What about the numbers in this area? So we'll pick negative 5. Negative 5 squared plus 4 times negative 5 minus 12 is less than or equal to 0. This is positive 25. This is negative 20. So we will have 25 minus 20 minus 12 is less than or equal to 0. This will give us negative 7 is less than or equal to 0. Is it true or false? This is true. What about the third region? So we'll have positive 3. 3 squared plus 4 times 3 minus 12 is less than or equal to 0. This is 9. This is 12. 9 plus 12 minus 12 is less than or equal to 0. This will give us 9 is less than or equal to 0. Is this true or false? This is false. So meaning to say that the only possible values of x that will make our inequality correct is when x is equal to or greater than negative 6 but less than or equal to 2. This is the end of the presentation on solving quadratic inequalities. Again, if you do have questions and clarifications, feel free to ask using our comment section down below. See you in our next video.